Hello civil engineers, welcome to my YouTube channel. In this video, I'm going to show you how to model, analyze and design roll-rise 3 stories building in Prota Structure. So here is the architectural drawing. So the first thing I need to do is to import this drawing to my AutoCAD. So I'm going to go to Insert, PDF, Import. So my drawing is in downloads. So this one, open. Okay. So you will wait for the PDF to finish converting to DWG, and then I'm going to open my Protastructure. So I need a new. This is Protastructure 2018. So I'm going to rename it sample. I'm going to call it sample. So I'm going to use the BS 8110. I'm going to import as it's converting so that we can start modeling the structure in our Prota structure, right? So it has finished loading. We'll remove that one and close this tab. So please, my laptop is a bit slow, bear with me, please bear with me. And because it's converting the PDF to DWG, so it's going to take a little bit of time. So actually Protastructure is a very good software, so you can learn it and it can help you in quick analysis. So because sometimes you need to do this work and deliver it in a very short period of time, so it will help you in besides manual calculations, right? So I need as it's loading. So this is how I prefer to model. I prefer to model when I'm modeling in Prota Structure. I prefer to model using axis generator. So it helped me to model very quickly. Let me first cancel. So let's wait. So this is how you do in real life. That is a building that was done in real life. So So almost. We are almost done. Almost there. Sorry for that. Yeah, I have some flu. No, sorry. For me, I don't like people. No. Sorry for my voice. So almost there. So please watch this video to the end. You will really learn a lot, because I have something that I want to show you, and please watch to the end. And if you have really benefited from this video, please don't forget to subscribe and hit the like button. So still loading. We're going to give it time, because my laptop is a bit slow, but it will finish loading the PDF, importing the PDF. So I'm showing you actually how it's supposed to do this in real life. You have been given an architectural drawing, and you need to start modeling and analyzing immediately. So yeah. Oops, it's taking a lot of time, but probably when you're on your computer it's going to do the same thing. Please bear with me. I should have imported this before, but it's also important to show for the beginners how they can import the PDF into AutoCAD. So I think this is also crucial for some people. And even if you will be using any other software, it will be helpful. Okay, I guess it's done, right? No, it's the other It's the other model that is closing, so don't mind. So can see we have it's a 3-story building, so it's 1, 2, 3, right? So you can see there is a water tank, right? There's a water tank there. So there's a water tank, and so we need to be able to interpret these. So from here I can see I think this is the ground floor, guardhouse. This is the ground floor. I think here is the water tank. It's right here. Okay. Here is the water tank on top, right here. So normally what many people would do when you are given this drawing is to scale. So you need to scale. So from my plan I can see that these two are water tank in the stairs. The water tank is right on top of the stairs, as you can see here, and there is also another water tank, water tank, water tank, water tank. So I just need this plan view to start modeling. So I can just do or I can just go to home and turn off some layers. So I could just turn off this layer. No, that layer is important because I can just copy this one. Just copy this one because I will need to see some things. The labels, they're important to me. I can just copy this one down here, control, or just copy from here and take it there. Then the next thing I will do is to I can open another new tab here because I don't know if I scale it, if the architecture did the scaling in the right way, because you might find he has labeled here 200, but when you measure after scaling it will be something less or more, a bit more. So but from the way he has given the dimensions here, it's the way he wanted it to be. So let me see. So I should open another new, and I will come here and I will copy this. So I don't need to just scale it because we change some things like the dimensions, and I need to use the dimensions. So I don't know which layer is this. PDF text. If I turn off this layer, it will turn off here. So I could just delete them. these that I don't want. So septic tank, okay. Soap pit, okay. Kitchen, dining, okay. So let me try to scale. First of all, I need to change to make sure the unit is in millimeter. D DWG units. So the unit is in 1, and from here you can see 1 is in inches. So I need to change it to millimeters. So millimeters is 3, so I put 3. Then enter. Scientific decimal, enter. Scientific decimal is okay. Linear display, enter is okay. Can just say yes, enter, enter. So the drawing is now scaled. I think the unit is now in millimeters. So we can just measure and see from here to here, right? Let me first confirm that the unit is DWG units. Yeah, it is 3. Yeah, and 3 is in millimeters, so it's okay. So the other thing now is to scale, right? So we know that this distance is from here to here is 200, and this is the grid. So the grid is in the middle of this beam, this 200 beam width beam, okay. So so we can just say that the distance from this grid to this grid is 8,200, because this distance from here to here is 8,000, and then there is 100 plus 100 plus 100, so 8,200, right? So let us measure the distance between the grids. So from this grid to this grid, escape it. No, I click escape. So it's 57.4004. So I need to find the scale, right? So to find the scale, it would be 8,200 divided by this. So I'll find the scale. So calculator, quick calculator. So I need 8,200 divided by, I think we have a divide sign here, over 57.4, need to be here, 7.4004, and then hit is equal sign. So the scale is this one. So I need to scale this, scale, and then specify the base point. Just click any point there and then give the scale, that one, 142.856147. So actually, yeah, I need to, that is the scale, right? So enter. So we can just check this distance. If so, you can see it's saying 80, 199, I don't know, but it's very close to 8,200, right? Because we had said that the distance is 8,200. So I could just simply come to dim style and then modify it. So baseline spacing, this one is okay. By block, that is okay, don't touch it. So arrow 142, 143 actually. I just make the arrow by the scale, increase the arrow by that scale. Text also, I can increase it by that scale times 4, so that it will be big enough. So 4 times, I can do 4 times. So this times 4 is about 500, right? Times 4 is about 550. So just put here 550. Just quick calculations, and then primary units. I don't need to precision, should be 0. Yeah, I need to be no decimal, so that that number will be 8200, and then OK, and then close. Now you can see what I was saying. Okay, so now so now we can find the distance, like the distance between this grid and this grid, which is very crucial in our modeling. So just from there, there to there. Then we can find the distance between this point and the other point. So I just come here and this point. So it also depends on the architecture specification, because we are not sure. So we can just start modeling, right? So I just trim some layers and just trim this layer. So let's go straight to modeling. Just select the entire of that and delete it. No. So let's go straight to modeling. So the other most important thing is we don't need to model the entire structure. Based on, if you know symmetry, you can tell that there is symmetry in this structure because there is a center line around this point. There is a center line around that grid. So you can see this. There is a center line around somewhere from, I think, here. Let me XL H. There's a center line around there. If you check so if you check, you can divide this building into two parts. You see, this one and this one. So but we need to model. We can just model. There are two symmetrical parts. You can see. You can just model this. Let me select from here, from this point, from this grid. You can see this structure here is symmetrical to from this is symmetrical to this structure from here to here, right? So we can just model this part and this part. What I'm saying, let me take a triangle, or let me take polyline, then show you what I'm trying to say. Wait a bit. So let me take a polyline. This, no, I don't need to snap it in some places that I don't want. I can just snap it in the intersection. Alright, so I just need to take the polyline, then from here to here to here to here to there to there to there to there to that point. So let me select the polyline. You can see that. So let me just change the layer color. I can just put it yellow, right? I'm trying to hit escape and I'm hitting F1 instead. That's why you're doing that. Don't mind. So you can see that I can increase the thickness by layer. Let me increase the thickness. So you can see that there is a symmetry. You can see that one, and there is another one here which is very symmetrical. Is symmetrical to that. Let me put another polyline here. here, here, there, so unfortunately I removed I deleted the limit there, I deleted the column there, which is now missing. Where did I go? No, this straight to this point, and then back to this point. Then I'm going to match properties, this polyline with this. So you can see, sorry for that. You can see the two of them are symmetrical. So what we need to do, we don't need to model the entire structure. So we can model it halfway, right? Because they are symmetrical in the structure. But the only trick here is that you need to model two structures, and the other one which is symmetrical to the other, you will just use the same design. So you need to model this, and now this here, because there is no other symmetry object with it. So you need to model this part, and this one, and one of these, either this or this, and then you use the same design for the other one, right? But you cannot, for this type, you cannot just decide to do from here to here, you see. So you just need to go up to the end, so and then we will use the same design for the other one, so the same as this one. All right, so let us model. So we'll model, it means we'll model from which point? From here we model this, from here we model this and this only, right? So I need the dimensions. So calculator, what I would do, you can see here is 2700, this line from here to here. So what I would do, I would not need to go and measure again, because it will take a lot of my time, and based on the scale that I put, there might be some error, and or even the architecture himself, so I just need to use the data that he has given here to start modeling. So I can confidently tell that, let me the calculator, that the distance between this grid and this grid is 2900, because this distance from here to here is 2700, and plus 100 plus 100, so plus 200 to 900, right? 2700 plus 100 plus 100 plus 100, and then is equals, you can see it's 2900. So this is my 1 2 3. So for where there is 1 2 3, we start by 2900, then comma, and then the other distance is this one I can just say 4100, just let me put it 41 for this point here, or just let us just model this, then we can offset the grids in Prota structure. So from here to here, from this point to this point, you can see it's 8,000, right? From here to here, which means from this point to this grid is 4000, because it is 8000 divided by 2. So which means that this distance from this grid to this grid is 4000 plus 100. Okay, 4000 plus 100, which is 4100. And then 4100 and then again 4100 times 2 times, right? 41. So we can just say 4100 times 4, or again this 4100 so just say 4100 times 2. Okay, then from there it's 1500 plus 100, this distance from here to here, plus 100, because the beam is 200 thick, so the grid is in the center, so it's 100, so it's 1700. 1700, and then again 5400 plus 200 again, which is and remember, we are not doing for the wall, the perimeter wall, this one we're just modeling the structure. Okay, so don't be confused why this is just the perimeter wall, the outside, the perimeter wall for the area. So we're not doing the perimeter wall, we are just doing the building, which is up to here. So it's 5400 plus 100 plus 100, which is 51 plus 2, which is 5600. 5600. So here we're done. So we need to go to the axis labeled A, which this axis, basically this axis. So you will note that from this point to this point is 5395, right? So 5395. So this point to this point, this point to this point, but it does not necessarily mean that the building, the axis is now in the center. So let us find out. We can just measure. Let us confirm this was in the center, because even by just looking, I can see. So here I can see it's 4200. No, actually 4100. So it can't be 4200. So there was an error there. That's why I told you that using these, what architecture has provided is very important, because you don't need to end up designing something that is bigger than he wants. Okay, so this grid we can just check it from this side. Okay, this grid from here we can check the distance from this other side. So because you can see when I measure here, it is giving me 4200, and we know what the architecture wants is this one to be, so which means it's up to here, from here to here is 4200 times 2, 8400, which is not correct, because 8400 is up to this point, then up to this point. So from here to this point is 8200. So you can see why I told you don't need to delete this architecture's dimensions. So we know we can just offset this one later. Let us just use this one. So from this point here to this point, it's 53.95, right? So and this beam is 200 is 200 millimeters. No, wait a bit. Actually, from here, from this grid to this grid here is this one. It is from here to here is 5400. You can see here plus 200, which is 5600. So we will offset this later. Just put 5600, not there, 5600 here. And then we know from here, from this point, this grid here, right, to this one is indicating from this one is indicating, this one is from which grid? Now this one here is up to this point. Okay, that is up to that point. So which is 53.95 plus 200, which is 55.95. So the other thing you need to confirm and ask for other more details from the architecture, because you can see even the architecture is also human, because you can tell that this distance cannot be, no, wait, this distance cannot be 50. There is an error somewhere. So this maybe we should check from the other side. Maybe we can just go with this outer one, and then this one is bringing confusion. You can just go with this outer one, and then we will offset some grid later, you know. So you can just go with this one, 54. So this grid up to here is 56. This grid up to here, let me just measure, but I know there will be an error saying that 105, right? And then let me measure the other one. Up to this point should be 56. Yeah, it's 56, so it's okay. Yeah, this one is okay. This one you can just measure, because as it is giving us the correct thing. So, and this one we measure. What was the problem with this? Actually, scaling is very important sometimes. That one cannot be like that. Never. So this one, that point is 3105. Then this point is 5600, and then the other point no, you don't need. up to that point, up to this the other point, because we already know there is 5600. So this point from here to here, this one was 2600. Okay, 2600, then 200, and then this one was 200. Okay, this one was from this side. So this point up to this point is actually 1500 times 200, 1700. So I'm just going to mark the axis that I have used. XL H. I'm just going to mark the axis that I have used. Then I've used that. I have used that. Then so that one I skipped. So then this one obviously we must use it. So up to this was 56. Up to here, so I'm going to add another one up to here, XL H, XL enter, H enter, up to here. There's another grid here. No, the center line is there. No, can't be. The center line should be here. That grid. So that's why you should be asking for specification, because even these people are human, but we know that this beam cannot be offset from this one. So I think this beam and this should be on the same line. So you should ask for specification from the architecture. So this beam cannot be, below this. So I will use 5600, and then you can tell that this is 1500 plus 200 plus 200, 1700. So remove this. And then I think from 5600 to from here to here is about, I can tell using the outer dimensions, is from this point here to here is 33.55, right? So it means from this grid to this grid is 35 55. So 35 55, and I have used these up to this point is 17 minus 35 55. So 1700 35 55 minus 1700 equals 1855. 55. The other may be offset. So from this point to this point should be 8950. 8950 plus 100 plus 100, which would be 8950. 8950 plus 200, which is equals 9150. So 9150 divided by 3. Okay, so I need to do 9150 divided by 3, or maybe we can use so I think the distance from this point to this point is 950, right? Let me check the dimensions. To 900 there, and then to 2800, and then no, not measuring the degree. I don't know what is what. What is this? Measure from this point. And 2850. Maybe when this one should be 2850. Let me see. That 50. So from this side, we could tell that the distance provided by the architecture was matching with the distance that we were measuring. So we can just use the ones we have measured, and even here. Right. And then here. Then from there. Yeah. So can say that from this point to this point is 3105, right? So 3105, then from this point to this point is 3000, because 2800 plus 200, 3000. Then but maybe we should not assume this point. Now we will offset it. From here to here is, from this grid to this grid is 3050. Because that particular dimension plus 200. We will offset this middle. From here to here is at 100, because it's this plus 200. From there to there, 3000. And then 3050 up to here. Then okay, let my reference point be 5000. So there is some lines that we need to offset here before we start modeling. First of all, I need to offset this from here to here. Let me find the distance. So that the distance should be 1500 plus 200, 1700. So I will offset this line by this grid by 1700. Offset by, click F2 on your keyboard, 1700. Enter. And then escape it. It offset twice. I didn't want that. So we can just measure. I think from here, from there to there should be 29. Yeah, it's okay. then measure from here to here, 17 here. Then we need to offset from here to here, but you can ask for further specification from the architecture. I will just do it 4100. No, I'm not going to put it 4100. I just put it 4100, and this one 5800. So offset. I'm going to offset this. No, let me first model before coming to offset, because you don't want confusion. Let's offset the one in this direction. So I need to offset this one by, I need to offset this line here by 5600. This one offset by F2 and 5600. So yeah. Is there any other one? We can offset this one by this plus 100. Offset this one by, because we have that line. I will need this line for this beam. Offset this one by 1195, and it is this one. So F2 1195 and escape it. Then I can just start modeling. Wait. Just start modeling. So I'll pick my beam. Beam from the architecture. We need a beam of need a beam of 200 by 300 thick reinforced concrete beam, and then here so we're going to use 200 by 450. But we should not start with beams because we are not placed columns. So sorry. So our columns are 200 by 300. This point. And see from the architecture my position of my columns. So I place them in this point, this point, this point, this point, this point, like that. Let me check, confirm. This point, this point. Then this point, and then this point, and then this point, and then that point. So I'm going to change the orientation. And then you can see from here, then there. So this point, this point, this point, this point, this point, this point, then that point and that point. So other columns is at this point. Have we added this point? I don't think so. So we offset, but we have this point, right? So I think we have this point. It is right here. So one column here, one column here. So I think it is this one column here. Then yeah. So we need to do further offsetting. So you can tell that from this point is 2600 from this point to this point. But remember that this beam is not in the correct place, because we don't want this beam to be down here, because we need this beam to in a structural general arrangement, this beam ought to be on the same grid with this beam. This beam for I can say that this is balcony, right? So we need to be on the same grid. So it means that it should be from here to here. I will measure. I just look this. We can just use 2600 based on the specification of the architecture. Even architecture is human, and they do this work, in rush. So sometimes they make errors. So you need to confirm from them what they wanted, exactly what they wanted. So I can also offset this one to 4100 and this one to 5800. And offset it again to 800. Just copy this property and then put it here, then there, then there. Okay. Now here we have balcony. We have balcony. And I think here from the architecture specification, this balcony, the column for balcony, because they will not be braced, because these columns are basically meant to hold this balcony, which is too long, so you need to be supported by columns. So I just put columns of circular 300 millimeters diameter. So change column here, I put it circular, I put it 300, then okay. It should be here, here, there. Remember, I'm going based on this. See here, 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 and then no here, and then there. There's no balcony, there's no column there, then there, then there, then there, then there. Yeah, we're done. So a structural engineer should respect the architectural drawing as much as possible, right? So we're going to now add our beams. 200 by 450. So I have right click. Don't be surprised if you right click, it will no. Let's see if I right click, it releases. It will release. And see, we are following we are respecting the architecture drawing. Okay, so there's a beam here, there, and there. Then up to that point. No. No. Then I will need this beam, this column there, and then this one should extend to this point. No, I don't need a secondary beam here. There's a secondary beam. No, does not make sense. We have columns, should put primary beam, alright? Because remember, primary beam are the ones which are being supported by column. So we didn't need a secondary beam there. So other beams right here. Now we have finished, we have modeled our structure. We can put the 3D view. So I can insert stories go to building setup, insert. I need 2 stories. One will be landing for stairs and the other will be first floor, right? So one will be, so 2 stories, then okay, and then I will come and edit story. I will come and edit story. The first story landing one should be 1500, the other one should be 3000 height, and okay, 1500 still. So a total of 3000, or we can just say 2850. We can just say 1425 and then 1425, so that it will be 2850. I just say our story is 2850, right? So then our foundation is often determined on site, so we can just put 1500 or anything, then okay. And then I will carry this. This should not be here, should be on the first floor. So I will generate this story, and then okay. So I need to select this one before generating. Yeah, I did not select, then generate. I need this story to go here, everything, okay. So and then I will come and delete the everything in this story, because we don't need beams in the landing apart from the landing beam. So I'll come, I'll select the story, then I'll go to columns. I'll delete all the columns, select the first one, hold the shift key, and then the last one, select the first one, shift, then the last one, and then delete. Okay, and I also delete the beams, the first and then the last one. No, hold the shift key to select everything. Hope I've selected everything, then shift again, then delete. Okay, then I will come to this story, then I will select the columns, go to properties. I will make it length story 2 stories, okay, 2, and then okay, and then close it, and then save it, because if the software crashes we will lose everything and we'll start from the scratch. Make sure you save, because so I will go ahead and add my slabs. Okay, so here I don't think I need a secondary beam. I don't need this secondary beam here, so I can delete the entire of this, then copy this property, then from there, so I don't think I need another secondary beam there, okay, because yeah. So I'll go to plan view. I will insert my slabs. So I need 150 slab, cover 25, and then loads self weight. That is automatic. I need it to be dead load for room. Then imposed load is a school should be 4. Then update and then start inserting my slabs. Then we will go to the landing one, then insert the we will model the stairs. So just go to 3D. So I need this to copy this property, then right here. No, delete that, come from there to there thing. Yeah, that is okay. Close. That is the landing beam. Then we model our stairs. So I'll go to plan view. Our stairs. So this one I should just let me first delete and put it the right way. Should be here. And put there. And go to 3D and confirm it is the way it should be. Yeah. Go to plan view. So this distance from here to here, let me just measure, is 600. So we need to model the stairs, and from this one the stair hole is about I think the stair hole is 200. Go to architectural. So 50 by 50, stair hole is 200. You can just I think we can just measure it from there, from this drawing. The stair hole is 200, about 200. About stair hole is about, it's from this point to this point, from here there. Stair hole is about 200, but remember there should be symmetry, because I'm measuring from this side. I see. So it's about, I think it's about 2. That one you should have the architecture. So it's 200. So I will offset this by 2600 divided by 2, 1300 minus 100, 1200. Then this one I will offset by negative f2 negative 1200. Enter. Then I will come and model. Not first model. I model the plane. I model the plane. Model the stairs first. Then I put the plane. Then slab. Insertion is pick points. Okay, I pick this point, pick this point, this one here, this point, and then that point. I will first measure the distance because I'm not sure, it seems to be too long. No, there's something I'm missing out here. I think the distance for landing one from here to here should be around 1500. So I will set this by 1500. And so that by 1500. So I model my stairs, insertion, pick point, then there, yeah, yeah. Then just close it, then properties, then copy the property. So right click and then click property, and then again insert from there, there, then insert from there. Okay. Then I'm going to edit this property. Remember, this is stairs, so slab does not contribute to the floor diaphragm. Update, close, property, load, tick here, update, then start from there to there. And then I will go to plane. I will start plane, right? So this stairs is going up, then this is going down, the other is going up, this one is going, so I define the plane for this. And maybe come here, 2 points, okay. from here to here to here to here. We first save. Now we pick axis, because pick this axis, pick this axis, pick this axis. Then don't know why it does not want to insert. Come back to that later. Go to 3D. No, I think I can tell the problem. I think this one should not be extending. Plain. No. Never seen anything like that before. Has accepted to place there. There's a problem in this. I don't know why is it behaving like that. So I may just delete this, then start it again. Properties. Yeah, it has accepted. Don't know why it was being like that. So this one Z3 should be, let's see, 1 2 3 should be negative 14 25, because that is the story height. And then I will update, then close, then I will properties. This one now should be positive. First of all, I will close, then select and select these properties. This should be 14 25, and then delete to 0. Update, close. I need to insert again because it has deleted itself. I don't know. Properties. Now this one will be positive. Delete that and then update. Then close. then move member to axis. Move member to plane definition, then properties, close, move members to plane definition, yes, then 3D. Then the other thing I will need to do is to insert the walls and the parapet, right? So I will insert the walls. You can see where my walls are being placed. So this one has a wall, this one, this one, this one. So I will place the walls in that manner. So, and you can see the walls. So here there is no wall, and here there is no wall, and here there is no wall, here there is no wall, here there is wall, 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 then wall, right? So, and the wall I think is 200 millimeter brick from the architecture specification. Yeah, 200 millimeter thick. Right? Sorry for that. $200 thick wall. So I will create my walls. I will go to wall. I will define my walls. So I will insert the walls, edit beam wall, I will define beam wall load. So I go to plan view, then go to story 2. So wall, kind of wall, I need 200 millimeter brick wall. So the height of the building will be from my calculator will be 2.85, subtract the thickness of the beam, that is the height of the beam, which is 0.45, which is 2.4. So it's 2.4. And then here is obviously wall thickness is just 0.2. So we can just change. I will create our own. We can just use that, it's close to ours. So okay, so I will copy beam wall load and then select all the beams. That you hold the shift and then select. So remember there is no wall here. There is also no wall here, so we select that. this first floor, is wall here, then there's also another wall right here, another wall right here, another wall, no wall there, right? So another wall here, another wall here, another wall here, another wall there, no wall that beam here, 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 then there's a wall here, and here, here, there, select that group, there, 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 and then finally there, and then paste. Yes, so we can go to 3D view and see. So what we are left is the parapet wall, right? And the wall in this beam. So I can just I know the distance is, I can just edit, just define edit beam overload, then I use 140, then the height will be now 1.425 minus the, because it is now halfway, minus the height of, or the thickness of the beam, so is equals 0.975. Okay, then I will copy, then I will paste. Then I'm done there. Then I can go to plan view. Now I can copy again here, paste here, yes, and then I can edit. And see now the wall height is just 1 meter. Then I will copy, then I will paste this point, this point, this point, this point. Let me deselect this. Maybe there is another way to do that. There, deselect this and paste. There is no option of paste by dragging. Yeah, this is 20. Just paste. Yes. Yes. Then I will add that hole there. I will edit. I will add should be wall width. The width from here to here is distance from here to here. 100. So this one should be 15 1600. Then okay, then close. Then I will add here. Then add opening, edit 1700. Okay. Then I will also insert another wall here. Please. So I need to do another 3 stories, right? 1 2 3. So I need to add 6 more. So because if the first story was landing plus first floor, which is 2, this one also landing plus first floor, landing plus first floor, landing plus first floor, so it will be plus 6. So 2 plus 6 8. So it go to, I will save first. Again, the other thing that I need to do is to change the dimension of this column, because I have already, this building was already designed, so I know the size of this column, so I know this size will fail and I don't need a lot of work, but you can do it yourself. I need to change this to increase the size of these columns, the interior ones, because they need to be increased. Then I go to properties, something that I have selected that is not a column, that's why. So I deselect that. I need the properties, yeah. So I change this to 250, 250, okay. Then I change this to 350. Okay. Another thing, I'm going to need to change this to 225, because I should avoid there is no such column that such as 200 by 300. Should be 220, at least 225, because 200 will fail probably in spacing of bar. Then this one, then properties, should be 225. No, I'm going to edit to the all of them, then I will close. The other important point is, you should know that the stairs column, which are going to hold the water tank, should be bigger than the other columns. So that one, you should have that one in mind before when you are modeling. So they should always be bigger than the other, because the water tank is very important, and it is very critical. So we need to design to make sure that the columns are stable. So you need bigger columns than the rest. So probably I'll change it to 225 by 400 properties. No, now here is the one which is 225, right, and here is the one which is 400. Okay, now we can go to edit and then refresh connectivity. Then move member to axis. Okay. Now we can go to building and insert stories. They are now going to be 8 up to the last floor, and then the other floor will be the water tank, which will be the 9th floor. So okay, so I have inserted 8 more stories, so I need to edit the stories. So this story is landing 1. Let me label it landing 1. This should be first floor. Landing 2, landing 2, second floor, landing 3, third floor, landing 4, fourth floor. And then okay, so I'll go back to my first floor. Remember, I need to have a line load here for these toilets, right? So I need to have a line load there, these toilets. So I insert line load, used 400. Now wall height will be the thickness of the height of the wall, the height of each floor, which is 2.85, minus the thickness of the slab, 0.15, 2.7. I can use here, we can use 100, or we can just okay, update, then okay, then I will close, then I will save. So from there we can now generate our story. So I will go to my first landing, then I will generate it to all the landings. Generate story. So this one is I will generate it to here, then here, then here. So yeah, okay, yes, close, then ready, right? So I'll also generate, I'll go to this, then generate to here, then there, then there, then close. Then I will delete all the walls. Then I will delete this. Delete slab load, yeah. Then all my roof slab, remember the roof slab is not accessible, right, apart from this slab which is holding water tank. So this one is not accessible, so I will change the live load. So I will go to my slabs in this, select all of them, hold shift key, properties. So I'll go to live load, then 1.5 should be just just 1.5, then close. Then I'll save it. So the other thing, let us model the roof water tank. Okay, so we'll insert another story. I will insert another story, right? So I'll go to building, insert story. Then now there will be 9 stories because it's just now the water tank. Yes. Now I will edit the story. Edit the story. Now the last story, the height is just 2850. Okay. Then okay. Then I'll go to this story. Then I'll go to plan view. So this column, we want to model this column in the last story. So it's on J and I and J and then 10. Okay. So I'll go to the last I and J and then K, then columns should be rectangular. Okay, 400, 225, I and J there and there, and then 10 there and there, and then we will edit. I should go through a length of 1 story, then update, then close, and I select all of them. Go through a length of 1 story. Okay, close. Then I will save it. Then I will insert my beam for the water tank, still 200 by 450. And remember, water tank is very critical, so for me I think this distance might be a little bit too big, so I need to insert another beam right in the center. So I will insert another slab for the water tank. Now my slab for the water tank should be 175. And then the loadings for self weight. Now for the dead load, I will enter the value. For the dead load should be, let us assume 10,000 liters tank. 10,000 liters tank is same as 10,000 kgs, right? So 10,000 kgs changing into newtons should be into kilonewtons should be times 10 divided by 1000, right? So it will be 100 kilonewtons. So that 100 kilonewtons should be divided in this slab. So it should be 1000 kilonewtons divided by I'll measure the area. So we want to change the 1000 kilonewtons into kilonewtons per meter squared. So we need to find the area. So remember, this slab is just one tank, so one tank across the area. So I need to measure so 41 and then 2.6 times 4.1, 100 over 2.6 times 4.1. And then is equals, so I will add 9.38 plus the 2 for the 2 for partitions, or yeah, so it will be 9.3 plus, let's say 1.5, it will be 10.8. so let us edit the slab now. 175, then here load this one plus 10.8 plus 1.5 be 10.8. Imposed, yeah. So insert insertion by beam region. Okay, close. Then I will go to the other floor. Now this one now also should be properties. 5.6 times 2.9 divided by 100. 100 divided by the area. 100 divided by 2 point. Now remember there are two tanks, so it is 200 divided by the area 2.9 times 5.6. 5.6. .3 plus 1.5 should be 13.8. So 13.8. So I should just delete this. Then I need to insert a beam, the center, from here to here. Then I need to insert a slab, because there will be a water tank just here also. Insert a slab 175, 13.8 now, and then also still 1.5, then close. So you can see the load of water slab is very big, so that's why it is very critical when you are designing the slab for water tank. So I'll save. Now I'm going to copy the wall load and paste it. It's like parapet. Then I will paste it everywhere. The outside. So the parapet for the roof. And save it. Then I'll go to 3D. You can see now. Now I will do my analysis. So I will go to analysis, building analysis. I will check the model first. Let me check the model. Start. So number of error is 0. Now I go to pre-analysis. I will edit my material. I prefer class 16 to 20. Then I prefer this is column, okay, concrete column. So I prefer 16 and 20. 16 and 20. Okay. Beams also, and I prefer 16 and select 16 and 20. Okay. And I change the grade of steel to 460. Change the grade of steel to 460. Then concrete beam, then slab 460 also, and then rib 460, then links 460, and then the glass steel 16 to 20. My slab I prefer 10 and 12. Okay. My links I prefer 8. Okay. My links I prefer 8. Also 8. Concrete beams 16 and 20. Then I'll go to foundation, also for 60, class 16 to 20, diameter, select, then I choose 12 and 16. Links also for 60, I choose 8 and OK. Then I go to parameters. I want my soil to be 190. And lateral, no notional loads. Then I save sample by me, by viewers 1A1, then OK. So parameters, that's no problem there. Then I go to model, my beams section are flanged, analysis, post analysis, go back to pre-analysis, load generator. Okay. Yeah, check this one, create unfactored load. Then go here, notional load, wind, I check that one. Then click OK, because they are like 5 stories because of the water tank and stairs. Then OK, analysis, then I will start my analysis. Then I can just check arrow and arrow for the software to design everything for me, but you should do it, you should go to the design and do it, each of them. You should not do it that way, because I'm just doing it because my video has been too long, so I want to cut it short. But you should go to the design, go to concrete design and design each element separately. And you should also compare with manuals, calculations using Excel sheet, which I'll prepare a video for that also. So I can go to visual interrogations, and then I will check if there is any member is failing. I will check for design status, scene settings, visual interrogations, design status. Okay, so you can see all my members are passing. Okay, now I will design the slab. So I'll just need to go to this floor. We go to the last floor. I'll design the last floor and the first floor. I'll design this Let me design first the water tank. So go to, then none, then I go to strip, use it here, analytical strip, so that's how you go about it. Then I'll go to first floor, that is second floor, then insert my strips. So I can go to and just insert the strips. Go there and there. Remember, I'm holding the shift key, so that the control key, so that it will be orthogonal, like 90%, 90 degrees. Okay, so hold there, continuous from here. No. To there, then from here to there. So you can see I'm getting T9 at a distance of 250, right? But you can see for the water tank it is very critical, because you can see I'm getting a spacing of very close spacing of 200. Okay, so we will design the foundation. We design for footings, which is isolated footings. So I'm going to select, let me first select this one. Insert pad footings. Yes, so it is starting my footings, but also I prefer to do it each one separately. So it's because, and see, I've taken a lot of time to do this, so that's why I've decided to go the short way to make the video short. But you don't do that, because even here we will need square footing for consistency and uniformity on site. Now you can see we have done. So from here we can now finally go to load Prota details. Yes, save the changes, and then we will export everything, and then we will detail and draw everything. So guys, please subscribe to my channel. I will show you how to detail this, because we designed halfway the model. So the only thing you're going to detail the one side, as I showed you earlier on AutoCAD, and then you will just design the other side, which is symmetrical, or which is similar or symmetrical with the same design as the other side. So the details are loaded. So you now generate your drawings. And just draw you can see the drawing for the footings. Okay, now you have done. Please subscribe, hit the like button. So that is everything you need to know on designing, modeling and analysis in Prota Structure. So thank you guys. So after this, you can export this to AutoCAD. So all you need to do is to, and see even the columns, all you need to do is to click right here, and then you will be able to export into DWG. Then you can detail your drawings in AutoCAD, then export. So that's how you do it. So thank you guys, see you next time.